Welcome back to Main Characteristics of Rational Functions, Part 2. And I've got my example written up here already. So where should we start? Well, we should always start and see if we can simplify things a little bit. And this one doesn't have anything to do on the bottom, but maybe we can factor the top. You know, sometimes you can't, sometimes you can. I'm going to try my luck. So if it does factor, it would have to have a 3x and an x. This one has small enough numbers, I think I can just jump right in, and I don't need any fancy magic numbers. So I got to get a positive 2, so it's either going to be 2 and 1, or it's going to be 1 and 2. I'm trying to make negative 7, so I think I'm going to want 1 and 2 and make them both negative. We just see if that works. We're going to get negative 6 x's and negative 1x. So yes, that is working, but it doesn't really do much for us because we can't cancel anything. So that's okay. It'll help us to figure out some of the characteristics. So let's look at vertical asymptotes. Well, I can see the bottom, negative 3. It never canceled. So that's going to be a vertical asymptote. And points of discontinuity, well, just to make sure that it's clear that we did think about it, but we've agreed there are none. Moving on, horizontal asymptotes. Okay, what we're going to do is go back to the original. And we're going to look at the big picture here. Who's dominating on the top? It's 3x squared, or even just x squared that is dominating. And on the bottom, it's just the x. So that means this thing is essentially just simplifying down to x, which means if x gets bigger, the whole thing gets bigger. It doesn't just focus in on a particular value. And if x gets progressively smaller, the whole thing gets smaller. So the conclusion here when you get something like this is there is no horizontal asymptote because your function is just going to grow wildly heading one way and drop off wildly heading the other way. What about the oblique asymptotes? Well, I'd say by looking at it, this is a second degree on the top and a first degree on the bottom, so the answer is yes, there is one. We're going to figure out what it is, so we're going to use synthetic division. So we're going to plug in negative 3, and that gives us the coefficients of 3x squared, negative 7x, and the 2 constant. Bring down the 3 and away we go, that's negative 9. Add them together and we get negative 16. That's going to be 48. Add those two together and we get 50. Now, we know what's going to happen because we've done some like this before. So I'm just going to go ahead and write what the equation of the oblique asymptote is. It's 3x minus 16. Because we know the remainder part here will turn into 0 because we're going to be dividing it by x plus 3. Right? Just to make sure we're clear on that, this is how we would write the rest of it. And if x gets to be a very, very large number, this whole thing turns to 0. So there's our oblique asymptote. And what do we got left to analyze? X-intercepts. See if we got any of those. Is there any way we can turn the top or the bottom into, just turn the top numbers into 0, and there's 2, and there is 1/3. So those are the x-intercepts. Typically we would write them like this, 2, 0, and 1/3, 0, and y-intercepts. Now, y-intercepts means you just plug in a 0 for x, and then you want to see what is the corresponding y value. It's actually easiest to go to the original form and put in zeros for x. 0, 0 and 2 over 0 plus 3. So that is 2/3. Okay, well, I think that's all we need to do for this one. I'm not even going to attempt a graph, so I'm going to stop there, and we'll catch you later.